Welcome back. As I mentioned in my previous video on the topic of where I introduced gas laws, that we will look at least 2 to 3 laws per videos and try to work a problem or two to understand the concept better. And here we have it. So the first problem addresses the ideal gas law itself, okay, which is the most comprehensive of all the laws that I've written or told you. And so the first question reads, it is not safe to put aerosol canisters in a campfire because the pressure inside the canister gets very high and they can explode. Now, why does the pressure gets very high and explode is because of um, Charles' law, which again, ideal gas law comprises all other laws into itself. Okay, so when you increase temperature from the campfire, you increase the pressure inside the canister, which is why it explodes. Anyways, that's how ideal gas law is related to the Charles law. If I have 1 liter canister that holds 2 moles of a gas and the campfire temperature is 1400 degrees Celsius, what is the pressure inside the canister? So we write the ideal gas law. So let me get my pen. So what's the ideal gas law? Which is PV equals nRT, right? So whenever you use an ideal gas law, you make sure that you adhere to the units that I've expressed. That is, P must be expressed in ATM, but in this question, you're asked to find P, which means when you're finished up, you should only have ATM as the single unit that's left. And V must be expressed in liters, or N must be expressed in moles, or must be expressed in, well, that's a large unit, but it should have 0.081 liter atmosphere over mole Kelvin, and T must be in Kelvin. Okay. Now this question asking you what is the pressure. So we are trying to find pressure. Okay. We know volume is given to us, which is 1 liter. Okay. We are given moles. N is 2 moles. Okay. Okay. And we know temperature is 1400 degrees Celsius, but we want it in Kelvin. So we add 273 to it. So it will be 1673 Kelvin. And we know R is 0.0821. So that means if we put all these together in this expression, then we get the value of pressure, which is P times the volume is 1 liter equals N is 2.0 times 0.0821 times 1673 Kelvin. Now it's very, very important you follow these units for the ideal gas law. It's not so much important for the remaining of the laws except maybe Dalton's law, all right? But I'll let you know as we go. Because in other cases, your units cancel out. Here, units doesn't just cancel out. They do cancel out, but you want them to be in the right unit. Like you don't want this to be in liters and you don't want this to be in Celsius, then you won't be able to cancel the gas law constant, right? So keep that in mind. So pressure would be basically 2 times 0.0821 times 1673 divided by 1, which is 274 atmospheres. Okay, that's significantly high pressure, which is why you're told whenever you buy a aerosol container that you cannot put it in flame or keep it near temperature that gets very, very hot, simply because what happens here is, well, this is the ideal gas law, but it directly applies Charles' law, which is if temperature increases, your pressure increases. What does the Charles' law, it relates Gay-Lussac's law. Sorry, I meant to say Gay-Lussac's law. The Charles law is volume versus temperature, which also would apply here, but the volume of the aerosol container itself doesn't change. It's the volume of, the pressure is increasing. So pressure increases, temperature increases. Okay, that's it. We've done solving the ideal gas law problem. Okay, now Boyle's law. Okay, Boyle's law is, well, we said pressure is inversely proportional to volume. What that means is at say pressure 1, you have volume 1, and if you change the pressure, which could be increasing or decreasing the pressure, then you have a corresponding volume. Okay, so the pressure 1 and volume 1 are related, pressure 2 and volume 2 are related. But is there an easier way to write it? Yeah, sure, which would be P1 V1 equals P2 V2. V1 is the volume at pressure 1, V2 is the volume at pressure 2. Okay, now if you notice, if 22.5 liter of nitrogen at 748 millimeters of mercury are compressed to 725 millimeters of mercury at a constant temperature, remember this is at constant T and N, right? What is the new volume? Well, this is where you're starting with. So this is your V1, this is your P1, this is your P2, and you're asked to find V2. So you do not have to convert this to ATM because it's simply like the concentration start, concentration end, volume start, volume end that we did for a problem in 170 is very similar, so you do not have to convert it. So 22.5 liter times 748 millimeters of mercury equals 725 millimeters of mercury times V2. Now, what does Boyle's law state? Pressure is inversely proportional to volume. That is, if pressure goes down, volume should go up, right? So what do you see between pressure 1 and pressure 2? Pressure 1 is 748, pressure 2 is 725. So pressure has gone down from where it started. So we would expect the volume to go up. Let's see if our V2 is greater than 22.5 liters. So that would be 22.5 times 748 divided by 725. So it's 23.2 liters. Okay. So I know I asked some of you last time in the lab, and every one of you gave a different answer. I asked you, let's say you dive into an ocean and you go as deep as you can, and I asked you what would happen to the pressure inside your body, and some of you said it goes up, some of you said it goes down. Well, I have worked out the problem here, and let's see if you can figure out if you can use this idea of volume versus pressure to better answer that question. Does your body pressure goes up or does it go down compared to the pressure at the bottom of the ocean? All right. So this is the ideal gas law and Boyle's law. In the second video, we're going to try to do at least 3, which is Charles' law, Gay-Lussac's law, and Avogadro's law. All right. So stay tuned.